All right, welcome to the 4-3 notes on modeling with quadratic functions. We're actually going to skip some of this stuff that's in here because it uses systems, and we're going to actually make your life much, much easier. What we're going to do in this unit is we're only going to do this with our calculator. So we're going to take a look just at example 3, and I'm going to show you how to put this into your calculator. And all of you will be so happy because you get to use your calculator, and it makes you so comfortable, and it's like your whoopee blanket thing like that you carry around till you're like 11, and then people start making fun of you because it smells, and that's weird. So, all right. So using a quadratic regression, everything is the same. Okay, everything is the same as when we did linear regressions, except for just one button, and it's just in your calculator. If you have a TI. If you have a TI, when you go into the stat menu here, after you put everything in and you go to calc, you're going to go down to quad reg. If you have a Casio, when you go to the stat menu, after you put everything in, you hit regression, you're going to hit F3 for x squared. That's it. That's the only difference. Okay? Everything else is the same. For those of us still holding out hope that we don't have a we don't have a calculator, that's bad. So you need to get one, but really that's all there is to it. Okay, so let's go ahead and do a practice one. I'm going to need you to pause the video. Go ahead and put in, this is a predicted temperature from a meteorologist in Denver. Let's go ahead and put in a quadratic model for this data, and we're going to predict the high temperature of the day and at what time the high temperature occurs. Okay, so go ahead and put this data in, and then we'll check it, and I'll walk you through how I did what I did. Go ahead and pause the video now, pause, and put these numbers in your calculator. Okay, one thing, and I apologize on this, that if I went too fast, that you might want to fix. You'll notice in, we want the time, you're going to put the time in terms of a 24-hour clock, and that's my fault for not mentioning that. I left that part out. So if you need to go back and fix that, and what that means is for AM, obviously, and noon, you're going to put whatever number it is, but for 2 p.m., you can put that in as 14, like 1400, like military time. And we do that so that the graph comes all right. So if you need to pause the video right here and redo your graph and put it in military time, go ahead and do that. If you figured that out, awesome. If not, go ahead and do that and then unpause, and we'll check them. All right, so you fixed that if you needed to in military time, so it works. And then, all right, so here's the model that we get. We get y equals negative 0.329 x squared plus 9.798x plus 15.571. Okay, the high temperature. So let's take a look. In both calculators, I get. We'll look at the Casio first because it's right here. So I went to menu. I went to stat. I put all these in, I go to calculate, regression, and x squared, and there's where I get my numbers from. Now the Casio does something really nice for us, and it lets you copy it into your graph menu. So if I hit F6 and then hit enter, I've copied it into my graph menu. So I can just hit menu 5 and draw. Oops, I gotta select it. And then draw, and there's that. Now I did adjust my view window. Okay, I made my view window from 0 to 24 because of 24 hours in a day, and the minimum from 40 to 100 because we're talking about temperature. So there's my graph, and then I can just go to GSolver and I can find the max, which is the other question it asked us. It said, what's the maximum temperature? So it looks like the maximum temperature is about 88.4 degrees, and that happens at almost 15, so almost 3 o'clock. We could figure out exactly the time if we did 0.873 times 60 minutes, and we could figure out, whatever it is, 253, I think is what it is. So that's in a Casio. In a TI, I put it all in, and I go to stat, and I scroll over to calc, and then I go down here to quad reg, and I hit enter, and it gives me all the same information that the TI did. I just have to write it down, and then in the TI, I could then go to y equals and actually put these numbers in, and I would get the same thing. So, actually, let me do that so I can remind some of us of how to find the max. So 0.329, that's x squared, plus 9.798 x plus 15.571. 0.571. Alright, so let's graph that. And again, we can't see it, or we can't see all of it because of the view window, so I can do that. I can go to my view window, my x-axis, I really only need 0. We'll go out to, whoa. We'll go out to 25, and then for the y-min we'll say 0, it doesn't matter. If it's not the same as my Casio, there's all that. Alright, so graph. So here's the graph. And what we're looking for is the high temperature of the day, and temperature was on the y-axis. So I'm looking for the max. So some reminders for you calc folks about how to do that. Yikes. All right, so we're going to hit second trace, and we're looking for the maximum. So we need left bound. Is that on the left side of the maximum? It appears so. If you're not sure, just move it over a little bit, and I hit enter. And then we got to scroll it over till it's on the right side of wherever I think the maximum is. That looks good. We hit enter and then guess, and it gives us 14.89, so almost 15, and 88.5. So not the exact same numbers at the Casio, but remember we rounded these numbers and the Casio stored it for us. Okay, that's really the only difference. So at what time does the high temperature occur? That was, let's go back here for a second. That was 14.89 at 14.89 o'clock. That's a weird time. So let's see if we can figure out what 14.89 o'clock is, just to make sure everybody's on the same page, in case you had a question like this on a test or quiz. So 14.89 is the X value. The max was 88.5 degrees. Now listen, I know it says 89 right here. You got to remember that a quadratic regression is just a curve of best fit. It's not exact. So obviously the max is not 88.5 degrees. It should be 89. It went higher than that. This is just a model to use to predict. So 14 is 12 plus 2, so we know it's 2 something p.m. And then 0.89 times 60, that tells us at 53. So at 2:53 p.m. is when it gets its max of 88.5 degrees. Okay? That's it. That's it for this video. All you have to do is be able to put that in. If you want to go back and try this problem and make sure you get the same thing, go ahead and pause the video right here, get these times and predicted temperatures down, and then you can do the same thing. The question here is what's the model, and question 2, what's the high temperature? Same exact kind of question. So here's another set of data if you want to do a prediction for that one. Make sure you bring your calculators. Make sure you have a calculator. You're going to need them. See ya.